TTL Computer 2. Today we'll be taking a look at the status of our build of our Flash file system for TTL Computer 2. And we are all ready to go. And I am going to just do a soft reset on TTL Computer 2. We see it's doing our system check and something new. It has initialized our Flash file system. And we're ready to take a look here. And it's just a reminder, we have directory of drive 0. That's our read-only file system that stores files in our ROM memory. And we also have drive 1, which is our flash drive. And that is empty because we've had no way to store any files in there. But in our last video, we tested our IDE flashcard build and we proved that we could read and write sectors. And I've gone ahead and done the required coding to complete the Flash system driver for TTL Computer 2. And we are ready to take a look at that today. Just a reminder, here's our command set. Now we had our load command in the past, and that worked with loading files from our read-only system. That's been extended to load files from our Flash system. We now have the save command, and that allows us to save files to our flash drive system. And we have our remove command that allows us to delete files also from our flash drive system. So we're ready to go ahead and try and store our first file to the flash drive. And as you may or may not remember, we only really have one way of getting files into TTL Computer 2, and that's by doing an Intel hex load. And we're going to start that now, and we are going to send up our regression test program. Will be the first program that we load, and that's off and going. And I'll come back when that's loaded. Okay, so that is loaded into address 8000, and we can do a quick go to 8000 just to verify that that's there and running, and it is. Okay, so that's completed, and we are all set to try and store that to our flash drive. Again, there's a directory on our flash drive, so let's use our save command, save to drive 1, and our file name will be regress, and we know that that's at address 8000, and saving and done. So let's take a look now at our flash drive, and there it is. Here's our first program. Okay, so let's go ahead and load a second program, which is going to be our screen program. Select that, and that is going. And that is loaded, and that is loaded at address 9000. So let's go to address 9000 just to make sure that's there, and that is our screen program. Very good. Okay, so we are ready to save this now to our flash. Let's do save to drive 1, and this will be screen. And we know this is at address 9000. Saving and done. Take a look at our flash drive, and we have our 2 files now. Let's do one last file. And this is just a very simple test file. That's up and going. That's at address 8000. Let's just do go 8000, and it just prints out test. And let's go ahead and save this to drive 1, our flash drive. We'll call this test. We said that's at 8000. And that is saved. Okay, so there's our 3 test files that we have. So let's just a little bit of review of what we have here. I'm going to do a directory on our rev 0. Okay, so we have our 3 programs, and we have the information it provides. This is the address in RAM that these programs will get loaded into. This is our file size in hex, the hex number of bytes, and this is our logical block address. And this is the sector on the flash drive where this file resides, right? The beginning load location, storage location for the file. And we can see that this is 205, 208, and 209. Now, this is a key thing that our Flash driver code needs to maintain. When we save a file, the Flash the Flash system driver system needs to allocate space for each, space for the file to be saved on the flash card. So we need a system to maintain, where is where is free space on the flash card to store files. I originally had something more elaborate in mind, but when I came to implement this, I really skinnied it down. So the only thing that the Flash uh, driver system does is it maintains the pointer to the next free sector on the flash drive, and it just updates that, for each file that's added. So we see this always goes up: 205, 208, 209. And then here's our drive 0. Again, we have LBA, logical block address, but for drive 0, the LBA is the actual address in the ROM memory space where the file lives. But again, for the flash drive, this is the sector on the flash card where it lives. Okay, so let's try and run some of we've saved these things. Let's confirm that we can load them and run them. Okay, so that's our directory. So let's try and load from drive 1. We want to load the regression program, and that's loading and done. And we know that that's at 8,000, so we can go to 8,000. And there we go. That's our regression test program running. And that's completed. Directory again. Let's try our screen program. Load from drive 1, screen, and that's loaded. We know that's at 9,000. Go to 9,000. And there's our screen program. Directory again. And there's our test program. Let's try and load that. Load drive 1. Test. Loaded and done. And that's at 8,000. And that's that. Okay, so now we've exercised the save and the load. So let's take a look at the delete the delete command, which is remove. And we want to remove from drive 1. And let's just do something that doesn't exist, right? File not found. Remove drive 1. Let's remove, let's remove the screen program. Yeah, let's remove the screen program, right? And here it's asking us to confirm, do you really want to do the deletion? Yes. And we can see that the screen program is gone. Let's see now. Now let's show you one other thing. Let's take and we're going to load another program, and we're going to load the test program again, just because that's really small. All right, so we've Intel hex loaded that. That's at address 8,000. Now let's save this to drive 1, our flash drive, and we're going to call this just TST since the other file's already there. And that's at address 8,000. Done. Now let's see what we have. Now, okay, so here's the program that we just saved. Now, so it's kind of interesting, or you might be saying, well, why did it add it in the middle there? Why didn't it get added after the TEST test program? And the reason why that is the Flash driver, when it's going to save a file, not only does it have to know where is a space on the flash card, where's the logical block address it needs to live, it needs to also find and allocate a place within the directory structure, right? This is all maintained in a directory structure in memory. It needs to determine which directory entry that this is going to live in. And so it has to find a free directory entry. And it starts at the top and it just starts going, right? This is directory entry 0. This is directory entry 1, 2, all the way up to 31. So this was the slot for the screen program, which we deleted. So uh, the code that looked for the free slot saw that this slot was free since the file was deleted, so it reused that slot, and that's how that got located there. But we can also see that the the sector allocations always increments, right? 2005, 2009, 200A. They always increase. Let's do let's do something else. Let's do all right, we already have the test program loaded. Let's load it. Let's save this again. We want to save this to drive one again. We want to use regress, right? Address, this is at 8,000. Now it's saying this file already regress already exists. Do I want to overwrite it? And we're going to say yes. So file written. Now let's take a look at what we have. Okay, so we took our test program and we just named it regress because we see these are all the same. All the file sizes are the same. Now the regress program before we deleted it was at address 205. Now we overwrote that regress program, but look at what the address is. It didn't use 2005. It just took the next free sector, which was 200B. So this while the save code reclaims directory entries that have been freed up from deletes, it does not reuse reclaimed uh, flash drive sectors. Those are gone. They're gone forever, deleted into the ether. So our file allocations always increment. So again, the file allocation started at 200, and they're going to continue all the way on up until the last sector is used up, which is I don't know what the sector numbers are. It's going to be FFFF is going to be the last sector number that's used. And if we ever get that high, the flash drive is going to be full. And that's okay. I don't think I'll ever put that many. We'll never put that many files on TTL Computer 2 on the flash drive that will ever get that high. But if we do, we would just have to reset the drive. We would just delete all the files. I would reset the logical block address to be 200, and it would just start clean again. So if we um, let's hex dump FC00, which is, if you remember from our prior videos, that's the file allocation table in memory. So we see we have regress, we have test and test, right? Here's our files here. And if we keep going down to the last 16 bits, right? This is the last row of the file table. And these last 16 bits are the free space point to the next free sectors on our flash drive. And we see it's O2 OC, right? These bytes are stored in little endian order, they're reversed. But this is O2 OC. And if we look again at our directory, we see that 20B was the last sector used, so 20C is the next free sector. So we would just have to reset that to reset the drive. Just some final thoughts on this is yeah, now that we have our read-write file system, our read-only file system is I'm kind of struggling to find a real a real use for this. Um, it doesn't seem like we really have much of a use for this at this point. So I don't know. I don't. I'll probably find some simple program that I might want to keep in there. One thing that's happening is that I'm starting to run out of code space in our ROM file, in our ROM chip for TTL Computer 2. And that stores all the code for our monitor and all of our system utility programs that all of our programs use to, to do all of our screen I/O and things like that. And a lot of our math functions are going to be there as well. So, I've already removed the export command. The export command, I've taken it out of our ROM code, and that will be a program that resides on our flash drive. But I may move other things out from the monitor as well, and move those to be actually utility programs that live on the flash drive. I might even do that for the hex dump or these the fill and the copy commands, and even the serial port stuff. I might move that out all to the flash drive to free up more space. So for our ROM code for our important things that we're going to have to add yet to TTL Computer 2, like a lot of math routines still need to be added. Okay, so that is our flash drive realized, and I think that's it for today. And we'll be looking at switching gears back to doing some work for Pilot, and that will probably be our next video. So until next time, that's it. Thanks for watching.